A free body diagram is a really useful diagram which shows all the forces acting on an object. Here's a box sitting on a carpet, and just say I want to come along and with my extremely artistic hand here, I want to push that box across the carpet at a constant velocity. Well, I could talk about all the forces that are acting on that reasonably easily, but one of the best ways to summarize it is to say, let's model that box as just a single dot, a single point particle. So we'll draw it just here as a single particle, and that is our box. Okay, so what are the forces that are acting on this box? Well, obviously the first one is one of them is the box being pushed by my hand. And which direction is it going? It's going to the right. So let's draw that force with its tail attached to that particle to show the push force. And I'm going to call it Fp. And in brackets, I'm just going to say it's from my hand. Or we could say it's from an external force. So that's something to remind us what is applying that force. So what's important is the size of the force, the direction of the force, and just keeping in mind what is producing that force. What else? Well, you know that acting on anything that's on the earth is the force of gravity. So let's attach the end of that to there, give that a little arrow to show that it's going down, and we can say that's the force of gravity. And what is providing that force of gravity? It is the earth. So that's just a reminder to us. Okay, now what else is acting on that? Well, we know that when you push something across a carpet, that it feels a resistance because of the force of friction. So as we add in there our force of friction, okay, and it's going the opposite direction to the way we're pushing because it's opposing that motion, and that's felt by the box, and it's because of the carpet. So the carpet is the interaction with the carpet that's forcing that box. Okay, if we then think, is there any more forces here? Well, the box is sitting on the carpet, and so it's being supported by the floor, by that carpet. So we need a force going up the way. Okay, and that is what we call the normal force because it's at right angles to the floor. It's pushing it away from the floor at all times. And we could say that's the carpet, or we could say that's the floor. Okay, so those are the four forces that are acting on that box in this situation. Turns out, as we'll find out later, that because it's just say our box is traveling at a constant velocity, then those the push force by the hand and the friction force by the carpet have to be equal, but we'll get to that. And I was going to also say, or I wanted to remind you to make a note here, that in force body diagrams, you always attach the end of the arrow to the object. And in general, the arrow size indicates something about the relative magnitude of that force. In this example, I've kind of drawn all of the forces being of the same size, and of course the force from the hand might be 10 times the size of the force from the earth, the gravitational force or the weight force, but if you were doing a careful analysis, you would make sure that the sizes were were proportional to the size of the force, so the arrows indicated the size of the force.